I'm going to propose a methodology to dynamically build profiles of users and places, starting just from trajectories that they have crossed in the past. And of course, the information that I have about these trajectories are the coordinates of each point, and I know when people have been there. After that, I will show you how this information I retrieved from the dataset helped me to make ranking, and so prediction of next places where people will go in the future. And after that, some extension about that work. So let me start with a little short story. Along this semester, we have developed in team places. This is my personal idea of geo-localized content-based search network. They actually won the workshop for web technologies and cloud development. This social network is based on flags, and there are some flags right now given here. The idea is that they are like posts, like the one you know on Facebook, but they are geo-localized, and you can leave them where you are, and if you go away, that flag will stay there, and if someone else will go nearby this position, he will find actually this flag. And in that moment, the new user will be able to comment that flag, and wherever you will be in the world in that moment, you will receive a notification about the comment, the activity that someone else has produced on that flag. So you can type down your thoughts, attach a picture, a video, and in the end, you will see a lot of flags around you. So in the future, the city will look like a little bit like this, or like that. And that could be a problem because you have too many flags around you. So the idea is to rank them in such a way that I can show to the user the most interesting on top of the list of all the flags. And since they are geolocalized, it's like if I'm ranking some places, so suggesting where to go to find interesting flags. And to do that, I need profiles about users to understand their preferences. So what's the process to do that? First of all, the main tools I have used. The dataset produced by this social network that is already used by around 100 users in 7-8 countries hasn't produced an enough big dataset to work for making statistics, so I used a dataset from the SNAP laboratory at Stanford University. And all the tuples in this dataset are mainly like this. I have the user ID, the timestamp when that user had been in a certain checkpoint, and the coordinates about the checkpoint. Besides that, I also have the friendship relation among all these users. After that, since these data are connected to an app, I needed to understand this data. So I built a web console in JavaScript to visualize that. And it's a little bit like this. Here you have other functions, but the main idea is that here, for example, user 98 has done a lot of activities in this area, so quite intense. After that, the most interesting external tool that I have used is characterized by Google Maps APIs for places. The main function, the most interesting one, is the nearby search, and that means that given a checkpoint, I can ask for all the potential points of interest that are around this point. And this is how these potential points of interest are organized. Each place will be categorized according to these categories. They are around 100. And after that, I worked on Java on this data to make web information retrieval and build a new dataset with more information than what I had before. So what's the main idea? For each user, I have trajectories. Each trajectory is represented by a set of places. What's the point? I have two problems. I have no information about these places but the coordinates, and I don't have information about users. So the idea is that I need to produce this information, and I have to understand if they are relevant or not. So, what's the methodology I'm proposing? This is an example of trajectory. I'm asking for the second place to the APIs, and I see that that place is here. So then I ask with the nearby search function what potential points of interest are close to this point, and if I find something, it's okay. Otherwise, I will make a quiz for further places. The idea is that, of course, the closer a potential point of interest is to the place, and the higher will be the contribution to that place to build this profile. What does it mean? That, for example, if you remember the categories I showed you before, let's say that this is going to be the profile of this place. So, for example, for the second categories, the point is 2, and for the last one is 32. It means that if this category is sport, this place maybe is based on sport activities. And after that, I will sum up all of them, and I will produce the final profile of the user. So I will use the inverse of the logarithm of the distance to weight all the potential point of interest that had to contribute to the final profile of the place. After that, I'm going to produce partial profiles. So how can I build this? In this case, this is only the information I have about the trajectory crossed by the user. And I'm going to take just the 50%, half of them. And according to the profiles of these places, I'm going to predict the next one. So I'm going to take the universe of all the places I know around the world, and I'm going to check where these next places that I know that the user is going to visit in the future are ranked here. So, what are the results connected to that? Actually, they are quite interesting because the idea is to show that this methodology I have proposed actually helps to make interesting ranking using just these profiles. I have used all the partial profiles built for every user, and I'm comparing them with the full version of the profile, so the 100%, because this will contain all the information I can know about the user. And I can see that at the beginning, when I have just the 20% information for, this is the top 10 places. So every line is, you can also look at that, these are the top 3. So at the beginning I can have this kind of misclassification, but going toward the end, the error is quite low. What about if I can use friendship relation as well? Well, first of all, here the results were already interesting, so the contribution that I can give here are not that relevant. Maybe they can become worse, but it doesn't happen. What is interesting is that here, I made the difference between the two errors. The average error made using just the profiles, and the error made using also the friendship relation. And when the difference between the two errors is 0, it means that actually the prediction is the same, so I didn't improve anything. What is interesting is that at the beginning, actually, I have some interesting contribution to the low percentage profiles I have built. And after that, I use the list of all 90,000 unique places that I have in my dataset. And I tried to compute the error of the misclassification in this case. And at the beginning, using 90,000 places, I started by 90% going toward around the 39%. But using just the next 50 places, that can be a real situation where you have just 50 interesting places around you, the error starts from the 50%, but they go down below the 24% using this methodology I have proposed for building these profiles of places and users. So after that, I started working on some further ideas to develop this work, because that were suggestions for single user. But the idea is when you go on holiday with all your friends, you can be interested in understanding where you could go all together in such a way that all of you are satisfied. And to do that, we need, from mathematical point of view, to understand which function we need to optimize. And it is by these 3 possibilities. Use the average profile of all the users that represent this group. Use the least misery, that means try to satisfy the least satisfied of the group. And then the variance function. That intuitively can be the best one, because this function will consider the standard deviation and the average as well, with some weights in the middle that has to be tuned, as always. And another point is to improve the recommender system algorithm, because this thesis is mainly based on creating on the profiling phase. And I'm using array multiplication to try to rank all the places. But the idea is that actually I started designing a new kind of algorithm based on two machine learning methodologies. One is the linear regression approach, and one is, yeah, I know, and the other is the stochastic gradient descent approach that is even better when we have lack of data. The idea is to build a design matrix n by n, where n is the number of entries and then the number of features. The features can be around 120, 100 are the categories, the same profiles I'm already using, plus 120 information that can come from friendship relation, other people being in the same place, and time of the day, for example. In the case of stochastic gradient descent approach, at every iteration I'm going to use a new entry, and I need some weights for doing the recommendation, and the weight of the tau plus 1 iteration will depend on the previous iteration with the eta parameter. How to do that, and I always almost concluded, is that I have to check the error. If the error is lowering in a significant way, then I will use that. I will try to change eta to see if I can improve my prediction. Otherwise, if the variation of the error I'm obtaining is very, very low, then I will keep that eta. And the variation of eta is represented by a multiplication with a factor of 0.5. So we have seen the main idea I proposed for building these profiles, the experiments made to understand what kind of contribution this methodology can give to rank places and suggest them to users, the main results obtained, and the future works based on this work. So, for whom of you are curious, you can now go on places.tk and you will find the social network that I proposed on which I placed this work. Thank you very much for your attention.